we can use similar triangles to help us indirectly measure things that we can't measure directly. For example, this flagpole. We're not able to climb it, and let's say we don't have a ladder that's able to reach up to the top, but I can use shadows and similar triangles to determine how tall that flagpole is. So here are two triangles, and you're probably looking at this diagram and you're figuring out a proportion you can write, and it turns out that yes, it is that easy. We are just going to write a proportion and find our missing value. However, we should probably talk about why the two triangles are in fact similar to each other. Well, we've been learning that to prove two triangles are similar, we need to have two angles matched up. If I can match up two angles in the triangles, I have enough to prove the two triangles are similar to each other. And so one of the angles that we have matched up is the 90-degree angle. We're going to assume that both you and the flagpole are both standing straight up and neither are leaning to the side. So there's one of our angles. The other angle that's matched up has to do with the fact that, I'm going to draw the sun up here really poorly, but there's the sun, and it has to do with the fact that when the sun's rays are coming in, they're coming in parallel, and so these angles formed up at the top of the triangle, or the angles formed at the bottom of the triangle, are going to be the same angle as long as we are measuring these shadows and heights, or shadows I guess, at the same time of the day, because as the day goes on, the length of your shadow will change. So as long as this is being done at the same time, we can use similar triangles to find our missing height. So there's kind of the why this all works, although you're probably dying to start your proportion, which now we can do because now we know the triangles are similar. And so there's various proportions we can write. As long as we're consistent, we should be fine. So maybe the proportion I'm going to write is x over 15, which would be the flagpole over the flagpole's shadow would be equal to my height of 6 feet, or this person's height, over the length of their shadow, which was 4.5. So there is one proportion that's consistent. That will absolutely work. In fact, if you want to pause the video and solve that on your own, that would be great. Let me just show you, though, that's not the only proportion we could write. Some people like to do this proportion. X over 6, which would be the flagpole over you, is equal to 15 over 4.5. So again, just to see that this is consistent, that's the flagpole on top over you is equal to the flagpole's shadow over your shadow. So we're consistent. In fact, if you want to again pause the video, you should see that you get the same answer when you do this proportion. Well, just because there's multiple ways to write a correct proportion doesn't mean everything's right. Suppose you tried this one out. Suppose you did, I don't know, let's say 15 over x, which is the flagpole shadow over the height of the flagpole, equal to 6 over 4.5. If you tried that one, do you see where the inconsistency happens? It's the shadow over the flagpole equals you over the shadow. And so that's not consistent. There's a problem. In fact, if you tried to solve that proportion, it would not work. The point of this all is, even though there's more than one way to write a correct proportion, there are ways to write incorrect ones. Not everything works. Anyway, hopefully by this point you've solved it. If I cross multiply and then divide by 4.5, I end up with a height for the flagpole of 20, and since we're doing a story problem, let's make sure we have good labels, and that flagpole is going to be about 20 feet tall, assuming our measurements were done correctly.